Party. Excellent. Well, I'm glad you're going to be glad you got up early to attend this session. We're going to do a lot of practical stuff here today. We're going to take a lot of the things that you hear about storage and apply it to real-world live situations running things like Oracle databases on AWS. So here's what we're going to cover. I'm going to do a quick intro because you don't want to hear me talk. You want to hear these guys that are actually doing this for a living. Not that I don't do this for a living. That didn't sound good. But I want to talk about enterprise storage challenges. We're going to talk about the way to configure an Oracle database using these different storage options. And then we're going to wrap up with a great customer case study where the customer is actually going to get up here and present. So storage options, if you've been using AWS, and I'm not going to spend a lot of time on this because I think people are familiar with this. If you're not, you're in the wrong session. You're at the wrong event. We have ephemeral storage, which you can use ephemeral storage sometimes, and we'll get into when you could perhaps use ephemeral storage. Elastic block storage, S3 for backups typically, and then Glacier for archiving, obviously, right? And then in terms of migrating data, one of the things we get asked a lot when people are doing enterprises is that we're running into terabytes and multi-terabyte systems. So, there's different options for migrating. You can obviously set up Direct Connect, but if you're not going to use Direct Connect long term, you can do import-export, which we'll talk about a little bit about in this session, as well as the storage gateways. And obviously third parties. There's a number of third parties out there. Attunity, you can use Tsunami, you can use UDP in order to transfer your data. So there's various options. You don't have to use a Direct Connect. And then some things that may or may not apply to storage options aren't traditional database workloads like CloudFront. That's more on the edge, right? So I'm going to quiz you early in the morning. And the point of this quiz is to not necessarily get these exactly right, but it's just to set the stage and to talk about the different storage options, the performance they can provide you, and what you might use where. So does anyone taking a look at the first one, a transfer rate of 1 to 2 megabytes a second, what would be that storage option? Yeah, EBS standard. That would be on a 16K block. And the reason I assume 16K is that typically people use 16K blocks when they're doing databases. In case you don't know, our Redshift product uses a 1 megabyte block size. Not your typical. That's data warehousing, not OLTP. And OLTP people used to use 16. When we measure IOPS on AWS, we assume 16K block. The second one. What storage device is a single-threaded? So I might have given you a hint there. Single-threaded performance. 16 megabytes. It's too early in the morning. S3. Did you say S3? Sorry, I didn't hear you. Can you give him a prize later? What storage option has 32 megabytes to 40 megabytes per second? It can burst more. Can fall down, well, it's not going to fall down less, but it can burst up to 40 megabytes per second. Anyone? 16K block size. You have to do a little bit more math on this one. It's PIOPS, so it's provisioned IOPS, and I believe that, I should even know this, 2,000 provisioned IOPS, I believe, on that one. Someone else can check my math on that one. This is an important one. You have 4 PIOPS volumes, so provision IOPS volumes. I provision them at 1,000 IOPS. What type of instance? There's a number of instance types. I don't need to necessarily know the instance, but what type of instance, what kind of network are they going to have? Now yes, it'd be anything. Nice. See, this is the thing. You can't be wrong up on stage anymore because people can check on the internet. To be more general, it's anything that has a 500 megabyte 0.5 gigabyte connection to the instances. Something we released recently that we didn't really release a lot of this information about 5, 6 months ago. We now release what the network bandwidth is for an instance type. So different instance types have different network bandwidth. So some have a gigabit, some have 0.5 gigabit. So you'd have to look at the instance type like he did to figure out how much you're going to saturate your network. The reason this comes into play is that at a certain point, you're only going to be able to push so much traffic out to your instance. What storage option produces about 100 to 145 megabytes per second? You got it yet? Did you Google it yet? Yeah, exactly. So think Redshift on this. So the high I/O instances that are on Redshift, and the reason they can get that performance is, yeah, and they're on ephemeral. They're not on EBS. They're on ephemeral. So ephemeral is going to be faster. So the point is not necessarily to know this number specifically, it's the fact that ephemeral is going to give you faster. And then if I wanted to transfer, I gave you some migration options. What if I wanted to transfer and I wanted to transfer about 3 terabytes a day? Does anyone know what? You can't answer that. You're part of the people that are presenting. Storage gateway. So I say approximate because a lot of these numbers, it's going to depend. But these are good numbers to start with. Yeah, when you're moving from on-premise. So Thru and Ravi are going to go into more details on when to use these various storage options, and I'll turn it over to them right now.
Great, thanks, Tom. Am I mic'd? Great, okay. Thank you, Tom. So that was Tom Lazowski, by the way, solution architect from AWS. So my name is Thru Saragopan with Apps Associates. We are a company that is doing quite a bit of work with the Oracle technologies. We've always done work with Oracle technologies, helping deploy enterprise solutions for Oracle environments. So some of the background that we bring to the table here is leveraging the knowledge, working with the various AWS-based storage solutions and mapping those capabilities that you have in AWS to what you would typically do for enterprise workloads. Okay, so let me get started quickly. We have some good content to cover. Please feel free to stop me at any time for questions, but as we sort of go through this, we'll either answer right away or definitely follow up with you at the end. Typical enterprise storage requirements challenges, right? We look at them across performance, durability, cost, etc. How does enterprise take care of this today? Right? SAN, local storage, SSDs, the various capabilities that we have today. How do we address durability with the different RAID technologies and capabilities that are built into these various storage solutions? Cost perspective, they're all high CapEx activities. Buying a SAN, buying different kinds of storage devices, buying for capacity that you don't need right away, but you're buying for what you think you might have to use over the next 2, 3, 4 years that you're depreciating that investment. Okay? Elasticity and scalability, how do we handle that if your database environments require more storage? Is by buying enough ahead of time so that you're able to provision it and have it there. So what can AWS do in this kind of a scenario? How can AWS help? Performance. We'll talk about how we can leverage provisioned IOPS, elastic block storage, some of the ephemeral SSD capabilities to put solutions together that can give you enterprise-level performance for your storage requirements. Durability and availability, similarly handled by replication across AZs and a few different technologies, and inbuilt capabilities. That is pretty important. Inbuilt capabilities that elastic block storage and S3 devices can bring to the table. Cost. I'm sure this theme has been talked about several times during this event, so I'll just leave it at that. You only pay for what we use. And elasticity and scalability. Add as you need and use as you need to, and drop them and not pay for it anymore. This is generally true. And I say generally true because when we're looking at database technologies, when you're looking at certain kinds of enterprise workloads, it is not just easy as adding another 500 gigabyte volume and say, go ahead and use it. Right? Quite often we're doing some things with it. It's probably part of a subset of different devices that are put together, different storage devices that are put together. So we have to be careful, but in general, it is very true that you do have the ability to scale and consume storage or release storage as you see fit. How many of you attended the presentation, I think it was a repeat session, both Wednesday and Thursday, by Miles Ward on elastic block storage? Great, a few of you have attended. Those of you who did not attend, I'll definitely recommend that you look at it on YouTube or whenever it's published. It had some fantastic details about some of the throughput that you can get for the different storage solutions, mapped to instance types, and data that otherwise hasn't been seen very much even inside AWS was presented there. So some really good data, good technology. What we want to do here in this presentation to talk about how would you put those things together, understanding what can give you what kind of performance for a database, for a file system, for different kinds of workloads. How would you mix and match them, and when would you use what? Okay, so you're going to see this slide or this representation of data repeated a couple of times as we go through this. So starting with this, what are some of the typical enterprise workloads? Databases, binaries, essentially application software, right? File server, files that are being accessed in and out, and backups and archival requirements. Looking at them again across performance, durability, cost, and scalability, what are some of the typical characteristics that you have to work through, right? Databases, low latency. We want very high performances, right? The durability and availability has to be pretty high. Backups, we say the durability is high, but availability is low in the sense that you're not looking for the backups to be instantly available, immediately accessible. Hence, the capabilities to use S3 and Glacier to be able to get it. It's very durable, but it doesn't have to be as available as database storage needs to be. So certainly don't have to go through it in much more detail. I would like to talk through how do the AWS technologies map to this. We can come back and look at how we are going to handle these typical storage requirements as we go forward. Okay, let's look at them. Ephemeral store. So why are we starting off with ephemeral store in the first place and not with elastic block storage? Because ephemeral stores are essentially locally attached disk drives to the instances that you're spawning. Not every instance is going to have ephemeral stores, or the instance stores as they're called these days. Certain instance storage do not have it. And they're also not persistent. Right? As we all know, the data is going to be lost if you stop the instance and restart and stop the instance again. However, if you're doing a reboot of the instance, okay, the expectation is that the ephemeral storage will come right back and the data will be there. But you certainly don't want to count on that in case there's any kind of disruption in the reboot process. But however, you're stopping the instance and restarting the instance at a later time, that instance could be launched in a completely different rack, different area, someplace else. There is no guarantee that the storage is going to be there. So therefore, as a best practice, it is nice to have that available and be able to perhaps keep your swap space, something that you need to be able to go back quick and fast. Some maybe temporary database table spaces, temporary table files that you can create and keep there. But there are some caveats that you have to be careful about. You have to make sure that you've bootstrapped certain kinds of activities so that a database comes up, it expects to see data there, it's there, or you do some kind of a recovery to bring it back up, so it can still be leveraged. The third bullet point here about zeroing out the bytes. You may have seen this being talked about at a few different places. So the key aspect here is that when you provision 100 gigabytes, 500 gigabytes of storage to your instance, when you go to access every block for the first time, AWS will destroy that block and make sure that there is no pertinent content there that you might otherwise be accessible as part of the data destruction policies. So we don't want to have that kind of an overhead when you're up and running a database operation, when you might reach the 60th percentage of your disk space, 70th, 80th. That could happen weeks, months later, because you typically provision for space more than what you would configure. So before we format it and put a file system on it, let's just go out and touch all the blocks, touch all the bytes. So that's a good practice so that you can not lose some performance, if you will. Okay. Some of the anti-patterns, essentially, what would you not want to do with the S3 storage, right? What are some of the things that you do not want to do? A couple of things is Because it is not persistent, if you're using it for database storage, we need to make sure that you can afford to lose it and bring it back up later on by making sure the database commands are properly entered. Okay? If you're required to do any kind of a snapshots, we can't snapshots instance stores ephemeral, so it's not a good use for that. Let's take a look at elastic block storage next. Okay, so we know the maximum IOPS that is available for elastic block store today is 4,000 IOPS. Okay, so quite often a database requires 5,000 plus IOPS. Most standard database environments, you want to consider at least 5,000 IOPS and more. So you're going to have to put a bunch of volumes together and use some kind of a striping technology. Quite often at the operating system layer, MDADM and different kinds of toolkits that are available. You may have Veritas Foundation Suite and other kinds of products that you could leverage to do so. So RAID 0 or RAID 1 plus 0, right? Striping and mirroring or just striping. These are some of the common considerations. Our experience, our recommendation has been to suggest just RAID 1. Sorry, not RAID 1, RAID 0. Just stripe. You don't have to necessarily stripe and mirror. Mainly because some of the performance penalties that you have, because the number of I/O that you have to do is going to be double because it's going to have to write against the other set as well. Mirroring, because remember this is software RAID, it's not hardware RAID. So your operating system is going to have to take care of making sure the primary volume and the backup volume are both written to at the same time. Unless hardware RAID is handled at the controller level, operating system just sends one I/O request. It doesn't understand that. So there are some general guidelines here in terms of what is necessarily best. And we're not necessarily protecting for failure of a disk storage when you're working with elastic block storage, right? It already comes with a certain level of durability behind it. 0.1 to 0.4% is what AWS publishes typically, is the failure rate of elastic block storage device. Okay? So we have backups and there are other mechanisms by which will typically protect against failures. I talk about database quite a bit because that is pretty much some of the focus towards the end. How would you configure an Oracle database specifically and work with it? Okay, one of the drawbacks, either of those, whether it is RAID 0 or RAID 10, is that snapshots and those kinds of technologies are going to become really complex. Because snapshot happens at the EBS elastic block storage level. You're snapshotting one elastic block store at a time. When you have put together 4 or 5 and striping across them, and you have a volume at that time, you can't snapshot the entire one together consistently. It's going to snapshot one at a time. So this is when you really have to work with whatever is the appropriate process, whether it's a database or a file system, whatever you're running, whatever might be the appropriate mechanism you have to use so that you can take a snapshot of the entire volume at the same time. Or do you? Are there any other ways to not do it and then take a look at some other approach in terms of how we want to do it? That's what we want to talk about again later on, is for database volumes, what are some of the best ways to do backups so that you can protect yourself against a failure of an EBS device in the environment. Okay, cost, yes, double the storage as you can expect. And during peaks, peak times for I/O specifically, you have the additional overhead having to write to stripes as well, or write to your mirror as well. Okay? So what are some of the best practices for using EBS, right? Optimized instances, EBS optimized instances. It's pretty much a given that anybody who's going to use provision IOPS for adding, guaranteeing certain throughput for your environments, you want to always couple that EBS with an EBS optimized instance. Right? We have a slide coming up that gives you a flavor of what are some of the instance types and what kind of network throughput and performance you can expect for some of these environments. Okay? The reason EBS optimized instances are recommended is because of a sort of a dedicated path for network I/O, for your I/O path between the instances and your EBS subsystem. Okay, when you're using just an EBS standard volume, the I/O traffic is going to compete with regular network traffic, whereas the EBS optimized instance has some level of bandwidth that you can count upon, so therefore they have better network performance for I/O that you can expect. That is hence the recommendation that we definitely want to use EBS optimized instances. There are different kinds of instances out there that can give 500 megs per second bandwidth, 1000 megs per second bandwidth. And if you look at the last bullet there, it says you don't necessarily have to worry about EDS optimized instances if you're using the cluster compute instance types. Right? Anybody take a guess as to why that is? It's a 10 gig network. Cluster compute instances are on 10 gig backbone, so you have sufficient I/O path already. Okay. The cost is just a small increment, 10 cents a gigabyte for standard EBS storage. If you're looking at EBS optimized, you're probably looking at 12.5 cents, about a couple, 2.5 cents increase for the EBS optimized and provision IOPS instance types. So this is actually the data that Ravi has put together. It's not very easily available today on the AWS website. The information is there in different pages or different contexts. Essentially, what it's doing here is to sort of give you a rough, mapping of your various instance types and the expected network performance throughput that it can provide, and whether or not some of these are EBS optimized or not, and then some flavor of how we can work them, how we can put them together. Right? Quite often, if you're looking for instance types based on certain memory and CPU combinations, you may have a couple of choices. So keeping in mind your network bandwidth, EBS optimization, and provision IOPS considerations would help narrow it down to probably the right choice that you need to do for the specific workload that you're working with. Okay? Some of this information could be outdated. I think there are a couple of slides that it's already been outdated from the announcements that have been made at this conference. So I'll point them out as we go forward. Pretty exciting. That's Amazon Web Services, continuous innovation. Provision IOPS best practices. So many of you, this is a 300 session, expected to be more complex and more technical in nature. So I don't have to explain to you about these statements, 10% of provision IOPS. But the key factor is that just because we're using provision IOPS, we're not going to get that unless it is coupled to an EBS optimized instance for those considerations just talked about, where you're going to get the bandwidth for network I/O. Okay. There is a discussions about queue length or queue depth that comes up quite a bit in terms of being able to maintain some optimum queue lengths for the IOPS that you can generate. I would definitely like to spend a couple of minutes on that soon. It's a pretty interesting concept, and you need to understand what exactly it's trying to tell you. Provision IOPS have the same consideration as the ephemeral store that I talked about. Just make sure we go and touch every single byte of that disk so that you have it initialized, if you will, for the considerations we talked about later. Snapshots. So this is actually, might sound like a bold statement when you sort of listen to some of the standard practices for protecting against data on EBS is to do snapshots very often. We have to keep in mind snapshots is also I/O. Okay, there is a penalty for that. If you're going to rely on snapshots primarily as a mechanism of backing up the data on EBS, yes, you have to. But other technologies, other means that you can look at for backing up the data. So perhaps you could have some kind of an optimal mix of being able to snapshot, or perhaps no snapshot at all for your database primary volumes. And we'll explain why that could be and how that can be. To Tom's point earlier about asking that question about 4 volumes at 1,000 IOPS and instance types, we could saturate. There are some optimal numbers for every instance types, that we want to stay in terms of how many EBS volumes do you want to attach to a single instance. So we want to stay within certain optimal numbers. The number varies depending on the kind of instance that you're using. Typically 8, 12, we could see the instance, the number of EBS volumes to be sort of restricted to somewhere in that range, purely from a performance capacity perspective, and not necessarily from any kind of limitations that AWS imposes. So queue length. So when do we get the best performance for a database? What is the queue length that you would like to see as a steady state? Right? 0. Right, so why would I want to configure for optimal queue length? right? When I want the IO, I want it. I want the database to do what it needs to do, so the performance is there. But however, queue length is important. You know, we have to be conscious of costs, and we have to be conscious of what we provision. Not everybody has the luxury of being able to throw all you can at every single database and then not have to worry about performance tuning later on. There is going to have to be some compromises and understanding of what we can put together, right? We walked into a customer that actually had a 800 gigabyte database, an Oracle database, a mission critical database running the ERP solution, very important. So we took over the production operations of the entire environment. So working through it, looking at the SAN capacity, hey, IO is fantastic. What do you guys have in the back end, right? So they have actually 6 terabytes of dedicated storage with some of the highest configurations they were able to get in an enterprise class SAN dedicated just for this database, of which it is only consuming 800 gigabytes. Okay, if you can do that, that's great. But that is a lot of unused space and a significant investment that could be used in several different ways. Okay, so what we're trying to say here is that if your interest is to get the most number of I/O operations you want out of a system to get the throughput, right? So yes, trying to make sure that the queue length is always out there because there's always some I/O going on and you're trying to maximize. If it's a game or a challenge to see what's the maximum I/O operation they can get out of a subsystem, yes, queue length is probably important. But in the context of a database and wanting to make sure that it's performing very well, we want to keep an eye on what is the queue length. We want to make sure that the queue length isn't getting higher, especially look at your non-peak levels and your peak levels and see what is equivalent, and then be able to understand, is your I/O where you want it to be and where you want it to configure it to be. And there are some interesting CloudWatch metrics that could give you that perspective that you can look at and understand. And if you seem to be hitting some thresholds that it maps to some of the performance or latency that you're seeing, you could accordingly make some adjustments and convert your volumes during planned maintenance downtime to something larger. Certainly that's the benefit of leveraging a utility-based computing model like AWS, is that you can make these changes without having to look at significant storage investments or SAN investments. Yes, it's going to cost you some time in terms of taking a database down to make these changes and bring it back up, but you do have the ability to be able to make those adjustments and grow with the database and your workload requirements as it grows. So some of the cases where perhaps EBS is not the right fit, right? Must never use this for swap disks, but I think this is a slightly older version of the presentation. We tone that statement down. It's not a question of must never use. You know, you probably, the local instance store is probably better used for your swap than an EBS volume. Quite often we have instances that have EBS-based boot volume, so you may not have the luxury of being able to put your swap on an instance store or a local ephemeral store. If you can, then it's probably a better location for swap, so you try to get the most I/O you can get. Okay, some general advice, you know, if you need higher durability, go to S3, but then again, if it's a database process, you just can't go put things on S3, so subject to statements. We got to look at the kind of workload and accordingly make some decisions here. Okay, data that requires very low latency, like session data, elastic cache and other things could help. But you could also look at your database technology very closely to see if there are some other features that are inherent in some of these databases that you could leverage and then be able to work with it, especially with the announcement that now we can actually have SSD available with some of the smaller instance types. For many of us in the enterprise, when you're trying to configure an Oracle database, right, we want to try to get some I/O performance. We don't have the luxury of being able to put 16 cores or 32 cores on a database just because you want to go after and get some SSDs, right? Licensing is a huge, huge consideration for enterprises. The number of cores that you have working for your database environment is a very important factor. If you only have 2 CPU licenses or 4 CPU licenses for an environment, you're not going to be able to use more than 4 cores or 8 cores. So you're going to be restricted to instance types that do not exceed beyond that. So how do we get the most I/O in that kind of a context? And the SSDs being available for some of the smaller tiers of instance types is actually going to be good. Once again, SSDs are ephemeral storage. They're not permanent. We cannot put any database files on it and reboot the system and find out they're gone, right? They're only ephemeral on AWS, but they do have a place. We can use them for many different kinds of IO-intensive workloads that don't need to survive across a system reboot or a system restart. Okay? Couple of quick tips to sort of be holistic about what we're walking through. I just want to talk a little bit about S3 and some of the best use cases for it. Backups. For Oracle environments, backups are pretty critical. How many of you are DBAs here, by the way, database administrators? Everybody, just a couple, okay? Oracle DBAs versus non-Oracle? Okay, most of you non-Oracle, got it, okay. The reason I say that is that you're taking backups, especially using Amazon and Oracle have jointly worked together to produce this Oracle Secure Backup module, wherein we can use the RMAN utility, which is the Oracle database backup utility, very widely used in the industry, right? You can use that and use S3 storage as your target backup media for RMAN backup command, right? So you can send your backup straight to S3. It's encrypted on the fly, and you have the ability to have multiple channels and then be able to actually have some pretty decent database performance. It can be even done from on-premise. If you have databases running on-premise today, and you would like to send your backups directly to S3 using Oracle Secure Backup, it's doable today. It's pretty decent. It can be done with a decent, most companies have decent internet bandwidth. You don't have to necessarily have a direct connect or even a site-to-site VPN tunnel. You go into S3, it can be configured, and it's a pretty effective solution. But the last comment here is that if you're actually running your Oracle database on AWS, and it's quite often inside a VPC, if you're an enterprise customer, you're definitely running it inside a VPC. S3 is considered an internet specific device, if you will, right? So your traffic have to go from your VPC outside the VPC to get to S3. So quite often in a VPC configuration is probably going to go through some kind of a NAT instance. So understanding the configuration of a NAT instance, especially its network bandwidth, right, is going to be important. A medium instance and a micro instance as a NAT instance is quite often sufficient for just whatever network connectivity your database server might require, download patches or Linux Red Hat patches from Red Hat Network or something like that. But we're going to be pushing data to S3. It's very important. And Chris is nodding his head because as we went through the deployment and reso, there was one area where we found some issues and having large instance type, especially instance type that has got, the network performance that you require as the medium to go to the S3 storage was pretty significant in improving some of the backup bottlenecks that we faced. Just want to point that out. Okay. In the interest of time, how are we doing time-wise? 25 minutes left? Okay, thank you. So I'll probably just click through this slide, if you don't mind. So here is the slide again I talked about. So what we've done here is that to summarize what we just talked about in terms of a database usage, applications, right, binaries, and then sort of put it all together against some of the Amazon storage solutions out there and map to what are some of the typical use cases or best fits, if you will, for where would you want to put your database files and transaction logs versus binaries. And some of this is intuitive. You probably may have already thought about this and this is how you're going to use this. Certainly, some things you should do, in our opinion, wherein it's common practice for some customers we have gone in to help with their I got stuff on the AWS, take a look, we're having some performance issues, things like that. They would see that just as one big PI apps volume has everything on it for the database, right? It's probably fine if you can work within some of those considerations. But however, it is possible to look at the characteristics of a database, binaries and reader logs and everything else, and sort of place them so that they are all an appropriate storage configuration. So we can, you don't have to over-provision for binaries with PI ops. It doesn't really need that much, but at the same time, we can have enough capacity for reader log transactions or index transactions, keep your backups away from PI apps volumes and things like that. Okay, so just an overview. These slides will be available, so I'm sure you can take a look at them in more detail. And certainly welcome any comment. If you want to challenge any of this and say, hey, why or how we see this different, very much welcome your comment. Our email addresses are in the back. I'll appreciate that. So let me quickly move into a short discussion around how would you configure Oracle database. And we chose Oracle because we have a lot of familiarity with it. At the same time, it is not very different significantly from other major database solutions out there, whether it's SQL Server or MySQL or any of those. I think some of the considerations definitely apply to a typical database environment. Okay? So database, one of the most expensive resources, everybody knows that, right? If your data can sit inside the memory, what we're showing here is the SGA, the System Global Area, which is essentially Oracle's database memory that you've configured. It's usually a contiguous chunk of memory, anywhere from 2 gigs to 8 gigs to 16 gigs or larger, depending on the kind of database you have. The data that the database needs, if it is sitting already inside your SGA, it's great. There's no I/O penalties, and you find your database is going to perform probably the best it can perform on that particular instance configuration without any I/O overheads. But that's very rarely the case, all right? So this is just sort of illustrates my previous point. When you, on the right-hand side, you see a cache head, meaning if your block is already in cache, you know, there is hardly any disk I/O time spent. It's all you're spending is CPU time. Whereas if you have a cache miss, the I/O operations are expensive. It's got to go to disk, read it, bring it back into memory before it can process that particular transaction for you with that data that it requires. Okay? So, but this is what happens. Data is continuously increasing. The number of users are continuously increasing. Not all the data that are sitting in disks on the bottom can actually be able to sit inside your memory. That SGA can only accommodate so much. So you're bound to have to spend some time, spend some energy doing IOs and configure for IOs and pay attention to IOs in the context of why we are today. How do we leverage AWS solutions to run database workloads? Okay. This graph here is actually interesting. What we're trying to show here is that CPU and memory can only do so much. I/O still dictates performance. What we're seeing here, just to sort of explanation to understand this graph, is on the bottom x-axis, we're showing number of threads. You can increase the CPU going from 100 to 800 in this example. And then what you see as bars are showing the transactions per second that you can achieve. So on the y-axis graph is showing from 0 to 800. So as you can see, if you continue to increase the CPU threads across the board, you can expect to get some significant transactions per second throughput up to a certain point. And after that, it's going to flatten out. Okay, 400, 800, double the CPU thread count, but your TPS hasn't moved significantly. Okay? The response times are latency, which is shown by that graph. The line that is going through on the graph is essentially showing that your response times are still fairly at decent levels up to a certain point, and after that you're going to suffer the penalty of having larger and larger response times. Okay, this is what I/O can do or can be a bottleneck for, and how important it is to make sure, especially in database environments, we have to pay a lot of attention to I/Os. So ASM, Automated Storage Management, is actually a database technology that has been in the Oracle database for quite some time. Came in 9.9, Ravi, or 10G? 10G. Yeah, the current version of databases is 12c, which is recently, within the last 1 year, it's been announced. 11G is the fully supported version. Pretty much most production deployments are running the 11G version of the database. ASM, Automated Storage Management, has been in Oracle database since the 10G versions. It primarily came in to help people run clustered database environments where you need to have storage, the database storage shared across multiple database nodes. And instead of having raw file systems or cluster file systems, Oracle came up with Automated Storage Management. But however, the point that we're trying to make here is that ASM can be used even for non-clustered single node or single instance database solutions. And why? It's because ASM is going to do what we have to do on AWS today to get the IOPS you require. It's essentially going to put a bunch of EBS volumes together, right? And with a logical manager, stripe across it and use it so you can get the IOPS that you require, and then be able to stripe the data across multiple volumes. We do that with the file system today. We do that with file system overhead, right? ASM can take care of that for you. So what we are doing here is simply adding the same, 400 or 500 gig volumes or 8 200 gig volumes, whatever you choose, and simply keeping them as device files. Yes, do the DD and zero them out, and present it to ASM. You don't have to put a file system there. The Oracle database software will take ownership of all of those disks, and it will do what is necessary to give you the performance. Okay, it'll take care of striping, and it's also going to be very helpful when you have to add storage. You may expect that you need a terabyte of data and choose to go with 250 gigabyte volume and put it in a logical volume manager and present it to your database. What if you need another 250 gigabyte volume? 250 gigabytes for database storage. You can add it into the volume. Some volume managers perhaps can, but they can probably expand or extend. But with what we can do today in AWS and the storage solutions and what you have to do, quite often you have to destroy that volume and reconstruct another 1.25 terabyte volume for a new database environment. With ASM, we don't have to. You just add another 250 gigabytes of the provision IOPS and simply tell ASM to take it over. And it'll even rebalance data, Oracle database files across. So it's a very powerful technology if you're trying to run Oracle databases on AWS, to definitely look at it. It has the ability to even do more things, stripe and mirror and things like that, but I'll leave that alone. I don't think it's important in the context of what we're talking about today. Okay, Oracle Secure Backup, I already talked about that. It's a great way of taking backups for database volumes. So, for a database, Oracle database specifically, this is a good working solution as to how you would put your AWS storage solutions together, right? Binaries, data files, read log files, essentially transaction log files, and pretty much every mission-critical database environment, we're going to be archiving your transaction log files so that when you do your daily backups and you have some kind of a failure in the middle of the day, we're going to restore your backups and then apply your transaction logs to catch up to the point of recovery, or at least before the point of failure. So we are pretty much always archiving a transaction log file. So, but it's just like an archive. We don't need necessarily PIOPS volumes or large PIOPS for EBS volumes to do that. It could be sitting on something else, something smaller. I'd like to talk a little bit about, again, the point that I made earlier about backups. Oh, that's probably the next slide, so pardon me. So this is sort of a summary pictorially representing what we talked about the database. What we're showing on the left, the prod data, is for your data files. Yeah, primarily table spaces that going to store your data, indexes, and system files and things like that. And then you have a recovery area that you typically configure for Oracle environment where you're going to keep your log files and things like that. So it could be done this way, using ASM. Okay, dev and test could be very much in the same configuration. We recommend it to be in a similar configuration because you can work through what do we need to do for production, regression testing, or changes and maintenance. You have a place to test them through. But they don't have to be 1,000 PIOPS or 4,000, whatever they are. You can configure them for a smaller amount of PIOPS, reduce the cost, and then still have a nice environment that you can test, regression test any changes you got to make. And backups to S3 is possible, okay? And then, of course, Glacier for any kind of long-term archival requirements. So database backups. So what is commonly discussed today about doing backups for data that is sitting on EBS volumes is to snapshot them, right? Many of the common techniques that are prevalent in the AWS world today is to take snapshots of your primary volume. So when you have them all clustered together or striped together across 4 volumes, as I talked about earlier, your snapshots now have to be synchronized. Therefore, you're forced to do some kind of a coalescing to do it. Yes, there are techniques where I understand that you can have replicated volumes, right? You can have a database replicating to another AZ, another sets of disks, and do your snapshotting there by coalescing the replication there. There are other options to do so and work with it. But however, what are we protecting against? Right? We're protecting against the fact that an EBS volume could potentially fail, right? So if you have 4 EBS volumes put together and you're running, using that as a database location, database data location, if there is a failure in any of those EBS volumes, even one, right? You have to throw the entire thing away. You have to rebuild all of your using your snapshots across them, and hopefully they're all coalescent effective. You rebuild that particular volume using snapshots. And we have to really work through a process of doing that and understand, first of all, how long it's going to take so that you can map your recovery window very clearly, and also all the steps that you're going to do. Sysadmin activities, database activities to be able to completely recover, run, and operate. Full documentation is going to be required because the last thing you want to do is to try to figure out to see how this thing is going to work when you have a failure in a production environment. Okay? So if you have some kind of a localized failure where a file got accidentally deleted, okay, you want to go after that particular file, right? If you're just relying upon snapshots for those volumes, however you're doing them, it's going to be a pretty expensive recovery process. Okay, it's probably good for a total disaster or entire loss of your database storage. You want to bring it back. Okay? However, if you're going to do, say, use the traditional RMAN backup and take a backup of your primary database and send it, every database has your standard backup utilities, send it to a separate file system that you have mounted, we're calling it /backupfs, whatever, it could be BIOps, it could be regular storage, depending on how big your backups are going to be. You can do the compressed backups as well using RMAN and send it there. If you have any kind of a local failure on your volume, you simply go and recover the file using RMAN commands off of your backups just sitting there. And then you apply transaction logs and recovery and up and running. Okay? So that is why in our approach to doing backups, we're not necessarily relying upon snapshots of your primary EBS volumes that are running your production data. We're more interested in snapshotting this, because this is still sitting on an EBS volume, the backup itself, on the node. So we would snapshot that backup to S3 so that it immediately goes. It's almost like if you're running a database environment today in-house, you have backup sitting in a SAN, and then you want to put it on tape, and the tape goes off-site, right? Something similar to that in that construct that you're a total failure, you can bring your backups back. That's what S3 can do for you with the durability and the fact that it's outside someplace else. So that can be done. And, or you can go directly to S3 bypassing a local storage. You're still going to have the ability to use RMAN to recover that one file in that kind of a failure scenario that I just described. Okay, so there are various ways to do this. This is a well-tested approach, and it works very well. And there are always ifs and buts about everything. What if this is a 2 terabyte database, 3 terabyte database, and RMAN backup is going to take a while, okay? Right, but if you're running 200, 300, 400 gig databases, quite often this is a majority of the chunk of enterprise level workload for various kinds of applications in the system. So RMAN backup is something we do today. Is your primary backup method internally in your traditional environment. So when you come to AWS, for several of the benefits that that technology does today, absolutely revolutionary in what cloud computing is doing. We don't have to abandon some of the things that we do very well today as DBAs and system administrators to take care of these environments, and it's possible to put them together and still have a very effective solution, very cost effective, and still get all the agility and the scalability that an AWS platform can provide for you. Time, I should go forward. Yeah, maybe what I'll do is just stop here and invite Chris to come on board. Chris Gattoni is IT Director at Reso. IT Director at Reso. Chris is going to talk a little bit about their experiences and what they did today and how they moved their enterprise workloads into AWS and what exactly is it. So, Chris, thanks for joining us.
Thank you, Steve. So I'll go quickly here since we're running short on time. My name is Chris Gattoni, as Steve announced. I work for a company called Reso. We're a $2 billion global company based out of Tokyo. And we sell and manufacture a high-end copier, digital duplicators, printers of that sort for the print industry. So let's get right into it. About 18 months ago, my company faced a lot of challenges on the infrastructure side. Our data center was very end of life, old hardware. For financial reasons, we were looking at our capital expenditures versus our operating costs. And the big thing was I was notified that we're moving our corporate offices, and my data center was shrinking significantly. And at the time, I was running 30-plus servers, probably a classroom-sized data center. I was going to a closet. So I had a lot of challenges right there, and we're very short-staffed, and we were just spending more and more time maintaining this old hardware. And I just wanted to get out of the hardware business altogether and focus on core projects for the company. So we looked at Rackspace, we looked at Azure, and we found AWS was the best fit for us. We were able to migrate a lot of our, get off a physical hardware, migrate to the EC2 platform. We lowered our total cost of operations, and more importantly, no data center to maintain, or a smaller footprint data center. And for once, I was able to run testing. If we have a new application roll up, I could very quickly spin up a new server, test it, and shut it down, whereas before I had to purchase something, find room in a rack somewhere, and the lead time was too long. So what did we look like before we migrated? Like I said, we had about 30 servers on premise in our corporate office. We also had about 5 or 6 sales offices scattered throughout North America and Canada. Multiple VPN connections site to site between all those offices, and each office had a SAN, it had a database, it had a domain controller, stuff of that nature, print servers and whatnot. So by migrating all this stuff to AWS, we kind of did a wheel and spoke. Everything, VPN connections from all my core offices now go right into AWS via VPC and VPN. So we migrate our Oracle ERP, our Oracle BI reporting tool, Lacrosse, which is a SQL database that we run internally, all our domain controllers, a product called Peen Identity, which does authentication with Salesforce for us, and our monitoring servers and our internal IT ticketing system all went to the cloud. And to do that, we wrapped it all up in a VPC with multiple redundant VPN tunnels between all the offices. And we restrict it via access lists and routing tables. So one of the big challenges, especially with the database side, as Dhiru was talking about, we had to use provision IOPS for our EBS stores for our databases. A big win for us is we replaced our tape library, so no more on-site backups. Everything was being backed up directly to S3. We saved a lot of money with off-tape storage as well. DR. We're working on DR right now. We're going to migrate, basically clone our VPC into a different zone altogether, a different region. Do a pilot light, just keep a small database running that replicates. If the main one goes down, we could quickly spin up all the AMIs in the VPC over in a different region. So when we did this migration, we really leveraged the entire AWS storage stack. Used the Ethereal for the swap spacing, EBS for all our OS volumes, the provision IOPS for our Oracle databases, S3 for non-production backups for our dev and test environments, also S3 for our storing our production backups, and we just recently moved about 2 terabytes worth of archival data that we were still sitting on tape, restored it, put it on a USB drive, and then import, export, and now it's sitting in Glacier. And then we're completely off tape. So one of the big challenges for us was, especially since we're running such legacy applications, and at the time with the office move and everything, I could not upgrade them. It just wasn't in the budget, didn't have the manpower. So one of the big challenges we faced was a lot of these applications don't only support 64-bit. And when we moved to AWS, their 32-bit offerings were slim, to say the least. Everything was 64-bit, which makes sense. So to work around that is we did a lot of load distribution, especially on the application tier of our Oracle database. Instead of having 1 or 2 Oracle 32-bit EBS instances, we spread it out to like 4 or 5 and just spread out that load between all of them. And we got the performance we need. And we increased our network bandwidth and stuff like that. And that's the solution EBS scale out right there. And we had to do some custom AMIs. We're running like Linux 3 for some of these applications. It wasn't available in the marketplace. We built a custom one, converted it to an AMI, and uploaded it to the VPC. So some of the takeaways, definitely make use of the entire storage stack. Every application, legacy, new, uses something different. You can mix and match them and find the right fit. No single option works for everything, so you sometimes have to play around to get the right balance between performance and cost. But a nice feature of this service is you can quickly turn something down and turn it back up, and your costs are minimized. definitely proper planning. Make sure you know what you're doing now. And I would say increase it by 10% because once you move it to the VPC, you're going to get network latency more than if it's just sitting like a room over from you, stuff like that. Definitely do a POC. Migrate your tests and dev environments. This is pretty simple stuff. Migrate your tests and dev environments first. Think about building a DR in the cloud. You can do it quickly and cheaply than if you have to do the capital expenditures to do it off-site somewhere else. And then finally, migrate your production workloads. And then monitoring is huge, especially the first 6 to 8 months. You're going to be playing around with this, touching it. You don't just spin it up there and you think you're done. You definitely have to right-size it over a long period of time and see your workloads throughout a year. And I guess we've got time for Q&A. Go back to Tom. Thank you, everyone. I know I went a little fast, but have a good one.
Thanks, Chris.
Yep.
Awesome. Well, thanks for coming. I hope we delivered on our promise of actually delivering you some content that has some real meat to it. I think it's always great to not just hear from the AWS person, because I can tell you a lot of stuff and you're not going to believe it because I work for AWS. But by hearing from a partner and an actual, I like the case study because it included all the different options and they used them in different ways. If you notice, they used import-export. They could have maybe used something else, but they decided to ship their disks to AWS and have them loaded. I don't know if we necessarily have any time for questions, but make sure, if you have any questions, be happy to answer them. If we can't answer them up here in the hallway, because they might kick us out of this room, but make sure to fill out your survey form. We want to get your feedback. This year, we've introduced at AWS more enterprise-level sessions, people dealing with, Microsoft, SQL Server, Oracle. So we're getting more enterprise sessions. In fact, last year, I don't think we had any enterprise sessions. So we want to make sure these enterprise sessions deliver on what we're promising, so next year we can make them even better. I appreciate you attending, and hopefully everyone has a great last day. Thank you.